Hello, this is Algebra 2. We're in Chapter 8, Section 3. This is page 1 of the notes. And at the beginning here we have this box about some rules for the graphs of rational functions. And what's going on here is, as you can see probably, the polynomials are going to get more interesting. Interesting is things math teachers like and often math students don't care for. The polynomials are going to be more higher order, higher degree, more stuff going on in them, and then you're still dividing them, and so you got to figure out what matters for what, and this is meant to help lay them out for you. It's one viewpoint on it. I will try to give a slightly different collection of what's going on in class. And then hopefully you can fuse the two together and make some sense out of it. So first of all, it says the x-intercepts of the graph of f are the real zeros of p of x. Now what this means is the x-intercepts come from the numerator. So then, for part 2, the graph of f has a vertical asymptote at each real zero of q of x. So the vertical asymptotes come from the denominator. Except I can't spell. Denominator. Alright, and then it says the graph of f has at most one horizontal asymptote determined by the degrees m and n of p of x and q of x. It says if m is less than n, the line y equals 0 is a horizontal asymptote. So it says m less than n. That means if the denominator is bigger. It says if m equals n, the line y equals a sub m over b sub n is a horizontal asymptote. So that's, if they're equal, that's because they have same degree, meaning the top polynomial is the same kind of polynomial as the bottom polynomial. And finally, if m is greater than n, then the graph has no horizontal asymptote. So let me write it out and then I'll explain it. So that's what happens when the top, or the numerator, is bigger. And in that case, the end behavior is the same as, goodness gracious, this is what you get. This is y equals a sub m divided by b sub n. That's the ratio of the leading terms. So I'll circle it here and point out that in blue that's the same thing as being circled here. And then it says x to the m minus n. M minus n is what you get subtracting the exponents because you were dividing the leading terms, the biggest terms. That's what mattered. So those are the rules, and then we'll move on to example 1. Okay, so we have example 1. It says graph a rational function, and then in parentheses it says m is less than n, and that's because the denominator is a larger polynomial than the numerator. So we have to graph this, and we have to state the domain and range. Well, we can talk about the domain and range plenty, but we've got to graph this thing first. All right, so first of all, it says the numerator has no zeros. Boom. And that's because the numerator is just the number 3. Can't make that 0. So there is no x-intercept. The denominator also has no real zeros. That's because x squared plus 2 can't be made 0. You could try to factor it. It won't work. You could try to use the quadratic formula. you would end up with I business, imaginary numbers and whatnot. So there are no vertical asymptotes. It says the degree of the numerator, which is 3, is less than the degree of the denominator, which is x squared plus 2. Except now it strikes me that we're not supposed to write in the actual numerator and denominator. We're supposed to write in the degrees. Okay, so let's try this again. The degree of the numerator, now the 3 is the numerator, but its degree is 0 because there are no x's there, is less than the degree of the denominator. Now if we look at the denominator is x squared plus 2, and so it has degree 2. It's a quadratic. All right, so the line y equals 0 is the horizontal asymptote. And we know that because from above, if you have something where the denominator polynomial is larger degree than the numerator polynomial, then the line y equals 0 is a horizontal asymptote. All right, so it says the domain is, okay, well, to be honest with you, there's nothing here that we can quite work with here. So let's try to plot some points. So let's stick in 0, right? If you stick in 0, you get 3 over 2. So 0, comma 1.5 dot. All right. Now if you stick in 1, you get 3 in the denominator, so 3 over 3 is 1. Funny story, if you stick in negative 1, you have the same denominator, and the numerator doesn't ever care about anything, so you have the same point, negative 1 comma 1. And so 2 becomes, the denominator becomes 4 plus just 6, so 3 over 6 is 1 half, 2 comma 1 half, and you can do negative 2 comma 1 half, same thing. If you stick in 3, it becomes 9 plus 2 is 11, 3 elevenths, which is, smallish number. On the positive side there. On the negative side, same thing. And you can see that the curve is something like this-ish. Boom. Boom. With arrows. Goes forever. Goes to that asymptote on the x-axis. And now you're ready to say, the domain, yes, okay. Oh, wait, no vertical asymptotes. So the domain is all real numbers. And the range is, well, you can see it peaked out at 1.5, and it goes down to 0. So it's all the numbers that are y, and they have to be more than 0 because they'll never actually be 0. And they go all the way up to 1.5. So you could write that as 3 halves, or you could write that as 1.5. It doesn't really matter either way. But notice that y is bigger than 0 because it never goes all the way down to 0, less than or equal to 1.5, because it does go up to 1.5. All right, that's all for page 1. Thank you for watching.